What is going on, guys? Welcome to the Python tutorial series for intermediates. We're now finished with the beginners tutorial, so we've covered all the basics, all the fundamentals of Python. And with this series, we're getting into the next category, into the intermediate concepts. Now, in today's first video, we're going to talk about object-oriented programming and classes and objects, basically. So let's get into the code. So let's talk about what object-oriented programming actually is. Now, object-oriented programming is a programming paradigm that tries to model the real world into the programming world. So we're taking real-world objects or real-world things and try to make them abstract models, or try to make abstract models of them in the programming world. So for example, we have books in the real world, we have computers, televisions, we have buildings and people and cities and all kinds of things, and we want to model these things into the programming world. We want to make abstract models of them. And to do that, we use classes and objects. And you can imagine a class to be somewhat like a blueprint of the object, and the actual object to be an instance of this class. So let's make an example here. Class person. And the class person, this is how we define a class in Python. Class, then the name of the class, followed by a colon, and of course everything that belongs to that class is indented then. And the person would now be, this class person would now be the blueprint of what a person looks like in Python. So we define what is a person, what attributes has a person, what happens when we call the method of a person, but we don't really say this is the name of the person. We don't really say this is the age of the person. We just say that a person has a name, a person has an age, and so on. So it's just a blueprint, and then the actual person, person one, person two, would be the actual objects. So how do we create objects of a class? We do that by calling the so-called constructor. And the constructor is just a method in our class that we need to call whenever we want to create an object. So we now have the class, and this constructor that we have to call has a specific name in Python. And this name is underscore underscore init underscore underscore. So this method here calls the constructor, or is the constructor, and it takes at least one parameter, which is self. And the self parameter is a parameter that has to be in every method, in every function that we define for our class, because it refers to the object that we're using right now. Because this is just a way to generalize what we do with our objects. A class, as I said, we're not going to work with a class. We're going to work with objects that are just an instance of the class. And whenever we want to access some attribute of that object, we have to use the self parameter, the self keyword here, because the self always refers to the object that we're dealing with right now. So we say def in itself, which means that we're creating a new object, which is now referred to as the self. And what I can do here, just let's just print hello world the first time. And to now create an object of that class, this is now a class that does not have any attributes, doesn't have any real methods, but we can create an instance of that class, which we do by saying person1, for example. Actually, you can call this whatever you want. You can also call it x, it's just a variable. And you can now say x equals person with a capital P, because that's our class name. We always provide the class name here. We can say x equals person, and we just call the constructor like that. So instead of saying person dot init, this is not how we do it. This is not the way we call the function. We just call the constructor by saying by calling the whole class, by calling the person class. And when we do that, we execute what is written in the constructor. So in this case, we print hello world, because this is the function of the init method, and we want to print that. Now, of course, this is usually not what we're doing, because usually the constructor is for initializing the person. So what we could do is we can say, okay, self, this object I'm dealing with right now has a certain name, and I can say self.name equals and I can create a basic default name like Mike again, and maybe an age, default age 25, I don't know. And whenever I create a person right now, this person will have the name Mike and the age 25. Of course, this is not what we want, but we can check how this works. So person1 equals person, and we just call the constructor. And we can then just print person1 dot name, for example, and print person1 dot age. So we can now access the attributes of that person. This is how objects work. And as you can see, it prints Mike and 25. Now, of course, we don't want to always have the same values, because if I make a person 2, I want different values. I want different names, I want different ages, and so on. So what we usually do is we pass some more parameters here. We say, okay, give me a name, give me an age, give me a height. And just a warning here, I'm going to use the metric system because I'm not a fan of feet and inches and pounds and so on, because simply for the reason that I don't understand this metrics, or I don't know how many feet is normal. So I can tell you 180 centimeters is a normal height, but I cannot tell you what a foot is, for example. So I'm going to use the metric system here. So let's say self.height equals height. And of course, we do that with all the other attributes as well. So self.age is just age, and self.name is just name. So what we're basically doing here is we're accepting some parameters, name, age, and height, and we're then assigning the values of these parameters to the actual attributes of our class, of our object, of the self object. So I can no longer just call the constructor, because when I do it, you'll see that I get a type error because it's missing 3 required positional arguments. And this means that when I call the constructor right now, I have to pass the values. I have to pass a name, for example, Mike. I have to pass an age, 30, and I have to pass a height of 180 centimeters. And then I can create an object. And then, of course, I can go ahead and print the height of that object as well. As you can see, I can print all the attributes because I have defined them. I have passed values for them. And of course, when I now define a person 2, I can pass different values, and it will not be always the name Mike. I can call the second person Sarah, or I don't know, like Bob or something. Now, of course, I can also change the values of the attributes. So for example, I have printed all the values, and now I can go ahead and say, I don't know, person1 dot name. Mike changes his name, so I'm going to call him, I don't know, Henry right now. And then I can print person1 dot name again. And you'll see that I can change his name, I can change all his values. Now, let's talk about some other default or some other predefined methods here, because init is not the only special method that we can use, because I can also define some simple methods here, for example, def hello world, and I always have to pass the self here, but basically I can just define all kinds of methods here that belong to my class, and then I can just call person1 dot hello world. So I can not only define attributes, I can also define methods. But this is not what I'm trying to tell you here, because what you can also do is you can not only define a constructor, you can also define a destructor. So what to do when the object gets deleted. We haven't talked about deleting certain things yet. We have not deleted variables, we've not deleted objects yet, but you can define a method del to determine what happens when you delete the object. So for example, we can just print object deleted. And basically what I'm doing here is when I delete the element, so I can use the del keyword. This is something that we haven't learned yet, but it's quite simple. When you want to delete something, when you want to delete a variable, an object, you just call the delete value, the delete keyword, the del keyword, sorry, and you can delete the whole object. So I can just del person1, and it prints object deleted. So the object is no longer there. It doesn't occupy any memory anymore. It's gone basically. And with the del function, the destructor so-called, I can define what happens when I delete it. But we're not going to use that quite often. So just so you heard about it. but I don't think that we're using it quite often. So another very important function that we can define is the str function. What happens when we print our object? Because it would be quite nice if we could just print the person. So print person1 to just get all the values, to just get all the attributes. But when I print person, I get just the object. I get just main dot person object at, and then I get the memory address. I don't really get any information that is interesting to me. What I would like to get is just a summary of all the attributes, maybe all the values printed out onto the screen in a nice format. And to determine what happens when I print my person object, or to define what happens when I convert it into a string, when I typecast it into a string, which is what happens when I try to print it, I can define a str method with 2 underscores. So again, self, and what I can do here is I can just say, we can now use string formatting that we learned about in the last video of the beginners tutorials. So name, placeholder, age, placeholder, and height, placeholder. And then dot format and self dot name, self dot age, self dot height. It's a little bit, yeah. So, and then again, close it. And when I now print person1, what happens is return the nonce. Oh, okay, sorry, I cannot print it. I have to return it. This is a mistake I always make. You don't want to print something because you don't want to take action. You just want to say, what do I get when I do this string? So what do I get when I print? Or what do I get when I typecast my object into a string? You don't want to print something, you want to return something. Makes kind of sense. So when we run it, we get this output here, name, age, and height. Because this is what we want to have when we have the string. When we treat our object like a string. Of course, I can just return some bullshit here as well. It doesn't matter. You just have to think about what you want to get when you print or when you treat your object like a string. Now, the last thing that we're going to talk about are the so-called class variables, because up until now, we've only defined attributes. We mentioned that we can define functions. For example, let's say get older by so and so many years, and then I can say, I don't know, self.age plus equals years, and I can make a person grow older, and I can make all kinds of attributes. I can define all kinds of methods, all kinds of functions, but we haven't talked about class variables yet. And class variables are variables that are not unique for each object, but are the same, that have the same value for each object. So one example for that could be the amount of people we already have. So let's just say amount equals 0. And every time we create a new person, we want to have this amount increased by 1. And of course, every time we delete one, we want to decrease that by 1. And I made a mistake here. You cannot just write amount, but you have to write person.amount. Now notice that we're not using self here because self refers to the object, to the individual object. When we access self, we access person1, person2, and so on. When we access person, we access the whole class. So in this case, we say amount equals 0, and then we say person.amount plus equals 1, and person.amount minus equals 1, because we're referring to the whole class. We're referring to one, actually this does not make sense. We're referring to the whole, to one variable that has one value for all the objects, because it's a class variable. And what I can do is I can just, let's delete this here. I can just print the amount by saying print person.amount. And you'll see I have one person right now. If I create another person, I don't have to do anything with that person. Just say person equals person, Sarah, 40 years old and 176. I will now have 2 the amount of 2. And when I go ahead and delete person 2, I will again have 1 because I created one and then I deleted one again. So this is basically how class variables work. If we want to have some values that are global, that are not only for this particular object, but for all the objects, for example, for counting how many objects there are, we can use class variables. So that was the first episode of the Python tutorial series for intermediates. We learned about classes and objects. In the next video, we're going to talk even more about object-oriented programming, and the episodes after that, we're going into socket programming, network programming, multi-threading, queues, and so on. So it's getting very, very interesting, and keep watching the series. So thank you very much for watching. Hit the like button if you liked the video. Subscribe to this channel if you want to see more. Leave feedback and ask questions in the comment section down below. And thank you very much for watching. See you in the next video. Bye.